Pulley misalignment is the leading cause of belt chirp on serpentine belt drive systems. In addition, misalignment shortens belt life and can cause the belt to run off the drive. That's an expensive problem if the belt damages a crankshaft speed sensor. Using a water spray bottle is a simple test to verify an alignment problem while the belt is still on the engine. But to accurately check for pulley misalignment, you need a laser alignment tool like this one available from Gates. It allows you to check all three types of pulley misalignment: parallel, angular, and pulley runout, which is misalignment from a bent component shaft or bearing wear. Here's the correct procedure for using this laser alignment tool. Before you start the process, make sure the engine is off, the belt is removed, and the electric fans on the radiator are disconnected. You will need a measuring tape. You will also need the laser tool and the laser safety glasses that are included in the kit. The special safety glasses help reduce laser beam glare on the pulleys, but will not protect your eyes from direct laser exposure, so use caution. First, measure the distance between the two pulley centers that will be tested. The crankshaft pulley should be the reference point for aligning all other pulleys, so we'll test the power steering pulley first. The acceptable tolerance for pulley misalignment is 1/2 of a belt rib for every 6 inches of pulley separation. The separation between the crank and the power steering pulley on this 4.6-liter Ford engine is approximately 6 inches, so 1/2 of a rib is the maximum misalignment. Second, turn on the laser and place the tool base into the pulley grooves closest to you. That is, the pulley grooves that are the farthest away from the engine or the accessory. The elastic cord included in the kit can be used to hold the tool on the pulley if needed. The beam should strike the top of the second rib on the target pulley, measured from the outside of the pulley. Third, test for pulley runout or a bent accessory shaft by rotating the target pulley and observe where the beam strikes the pulley rib. If the beam moves outside of the acceptable tolerance when the pulley is rotated, the accessory shaft may be bent or pulley bearings may be worn. Fourth, if alignment is within tolerance, reverse direction of the beam by placing the tool on the target pulley and direct the beam back to the first pulley. In this case, we'll place the tool on the power steering pulley and test the crank pulley. If the beam does not strike the top of the second rib on the original pulley, the pulleys have angular misalignment. If the beam is out of tolerance in both directions, it indicates parallel or horizontal misalignment. Now that we've checked the power steering pulley and found out it was out of alignment, we can then go back to the crankshaft pulley and we're going to check the air conditioning pulley, and once we find out that that's okay, we can then use that as a point of reference to check the other pulleys in the drive, such as the idler and even the alternator itself. This will give us a complete diagnosis of the system. The reasons for pulley misalignment are numerous. Always check for a bent or broken accessory bracket, which can cause angular misalignment. Also look for loose or broken bolts and repair as needed. Keeping your belt drive system in proper alignment will reduce belt noise and increase the life of your serpentine belt.